we imagine life on other planets, we often picture strange aliens or advanced civilizations. But for scientists, the search for extraterrestrial life starts right here on Earth. Our planet is home to extremophiles, organisms that thrive in environments once thought impossible for life. These tiny survivors can endure boiling heat, freezing cold, intense radiation, toxic chemicals, and crushing pressure. If life can survive these extremes on Earth, it might also survive in similar conditions elsewhere in the universe. By studying extremophiles, scientists gain clues about how life could exist on Mars, Europa, or even distant exoplanets. These remarkable organisms challenge our assumptions about what life needs to survive, opening our minds to new possibilities beyond our world. Extremophiles are microorganisms that don't just survive in harsh environments, they depend on them. There are many types, each adapted to a different extreme. Thermophiles thrive in heat above 100 degrees C, while psychrophiles love freezing temperatures. Halophiles flourish in salty places, acidophils in acidic environments, and radiophiles withstand radiation thousands of times stronger than humans can handle. One famous example is Deinococcus radiodurans, nicknamed Conan the bacterium, which can survive radiation, dehydration, cold, and even the vacuum of space. By understanding these organisms, scientists aren't just learning about Earth's biology, they're discovering the possibilities for life everywhere else in the universe. Mars is one of the most promising places to search for life in our solar system. Although it's cold, dry, and has thin air, some extremophiles on Earth could handle similar conditions. Psychrophiles thrive in ice, halophiles survive in salty water, and radiophiles can tolerate high radiation, just like what we find on Mars. In fact, some extremophiles have already survived Mars-like conditions in labs. Beyond Mars, moons like Europa and Enceladus are covered in ice, but hide vast oceans beneath. On Earth, hydrothermal vents deep in the ocean support life that doesn't need sunlight, relying instead on chemicals for energy. If life exists on these moons, it might resemble the chemosynthetic extremophiles found around Earth's deep-sea vents. Many planets and moons are extremely cold, but Earth's psychrophiles have special adaptations that help them survive sub-zero temperatures. Their enzymes work in the cold, their cell membranes stay flexible, and they can go dormant when conditions get too harsh. On the other end of the spectrum, thermophiles and hyperthermophiles thrive in boiling water near volcanic vents and hot springs. These heat-loving organisms show that life could exist on planets with volcanic activity, even if the surface seems uninhabitable. By studying these adaptations, scientists learn how life might survive in icy or fiery environments throughout the universe, expanding our understanding of where life could exist. Extremophiles teach us that life is far more adaptable than we once believed. They survive in places that would be deadly for humans, proving that survival doesn't require perfect, Earth-like conditions. Microbial life is the most likely form we'll find on other planets, and what's extreme to us is normal for these organisms. Their existence helps guide space missions, as scientists know what kinds of life to look for and what environments to target. Future missions will drill beneath Europa's ice, examine plumes from Enceladus, and study Mars's underground soil, all inspired by what we've learned from extremophiles. If life can survive the impossible here, the universe might be filled with life we haven't imagined yet. Extremophiles remind us that life is flexible, creative, and resilient. Survival isn't about comfort, it's about adaptation. By studying these incredible organisms, we learn not only about biology, but also about the potential for life beyond our planet. Life in the universe might not look the way we expect. It could be small, hidden, or incredibly tough. But if extremophiles can survive the impossible here on Earth, then the chances of life surviving somewhere else suddenly feel much more realistic. In the search for life beyond Earth, extremophiles are our greatest teachers, and perhaps our best evidence that we are not alone.